So I am tasked to have to answer the question 2. So for the question 2, an equimolar liquid mixture of benzene and toluene is separated into two product streams by distillation. A process flow chart and a somewhat oversimplified description of what happens in the process follows. So here is the process flow chart. Then inside a column, a liquid stream flows downward and a vapor stream rises. At each point in the column, some of the liquid vaporizes and some of the vapor condenses. The vapor leaving the top of the column, which contains 97 mole% benzene, is completely condensed and split into two equal fractions. One is taken off as the overhead product streams, and the other, which is the reflux, is recycled to the top of the column. The overhead product stream contains 89.2% of the benzene fed to the column. The liquid leaving the bottom of the column is fed to a partial reboiler in which 45% of it is vaporized. The vapor generated in the reboiler, the boil up, is recycled to become the rising vapor stream in the column, and the residual reboiler liquid is taken off as the bottom product stream. So the composition of the streams leaving the reboiler are governed by the relation y sub b is divided into 1 minus y sub b divides by x sub b over 1 minus x sub b is equals to 2.25, where y sub b and x sub b are the mole fractions of benzene in the vapor and liquid streams respectively. So the first question is, take a basis of 100 mole fed to the column. Draw a completely labeled a flow chart, and for each of four systems, which is the overall process, the column, the condenser, and the reboiler, do the degree of freedom analysis and identify a system with which the process analysis is might appropriately begin. So one with the 0 degree of freedom. So here is my flow chart. I hope you can see it clearly. So let's start with the 100 mole percent. Then it is take on the basis that uh, for the starters, it is 100 mole percent, 100 moles. Then it will go to the distillation process in here, and then it will have 0.50 moles for benzene and 0.50 moles for toluene. Correct? Yeah. Then here is the first one for the uh, vapor stream rises. And here is the liquid stream flows downward. So we have here the 2 and 1. Since the 2 and 1 will be separated as a reflux and an overhead. Yes. So the 0.97%, 0.97 is the vapor leaving the top column, which is taken into two simple fractions. So we have here the benzene, then for the balance, we have the 0.03 mole for toluene. Next, we have the XB, which we're gonna find later, which is the mole fraction of benzene, and N3, which is for the product going out the reboiler, and the N1. So these are the three things that we need to find for the next one. So here are the degree of freedom. So for the overall process, yes, we have the N1, N3, and XB, so the unknown. Then we have the two balances, which is the toluene and the benzene, then one relationship. Next is the degree of freedom for the overall process is 0, while in the distillation process, we have um we have 1, 2, 3, 4, 5, 6, 5 unknowns and 2 balances, independent equations. So we have 3 degree of freedom for the distillation and 1 degree of freedom for the condenser, since we only have the one unknown, which is the N1. For the reboiler, we have 6 unknown, 2 balances, and 2 relationships, which leaves a 2 degree of freedom. So since we're gonna start off with a 0 degree of freedom, then we will choose the overall process. Next, write in order the equations you would solve to determine all unknown variables on the flowchart, circling the variable for which you would solve in each equation. Do not do the calculations in this part. So here are the equations that I have set. So for the 89.2 recovery of benzene, we have this first equation. So this is the percentage. Then the 0.50, since they have a half mole percentage for benzene and toluene, then times 100 is equal to 0.97. The 0.97 is from the vapor leaving the top column. Then the N1 here is the variable that we must find. So 100, since it is 100 mole percent, is equals to N1 plus N3. The N3 is the product leaving the reboiler. Then enable to solve the XB, which is the mole fraction of benzene, we have this the benzene balance, we have this formula also. 0.50 times 100 is equals to 0.97 N1 plus XB and times N3. So this is the equations for the reboiler. This equation is a given on the first part, and we have this the calculation for N4 and N2. So and we have this for calculation of ZB also. But we are going to focus on these 3 main parts. So calculate the molar amounts of the overhead and bottoms product, the mole fraction of benzene in the bottoms product, and the percentage recovery of toluene in the bottoms product, which is 100 times moles of toluene in bottoms divided by mole of toluene in feed. So I have here the answer, since I'm going to show you how to solve it. So the 0.892 times 0.50 times 100 is equal to 0.97 and 1. So for here is we have so we have 40.6 is equals to 0.97 and 1. So N1 is equals to it's 44.6. So we have 45.97, 98. Then we're gonna uh, round it up. So, then it will be 46. Oh. Then for the entry, since we have 100 is equals to N1 plus N3, we know the value of the N1. So we have 100 is equals to 46 plus N3. Then we're gonna transpose it here. 100 minus 46 is equals N3. Then N3 will become 54. So we have 46 and we have 54. Now we can solve for this one. So in solving XB, we have 0.50 times 100 is equals to 0.97 and 1 plus XB and 3. So we know the values of N3 and we know the value of N1. So 54.62. Since we're going to have this as 46, the value will be 44.62 plus xb and 54. We're gonna transpose this in here. 50 minus 44.62 is equals to 54 xb. So we have 54. So we have 0.100 mole equals xb. So here is for the mole fraction benzene balance of benzene balance. So next, for the percentage of toluene, we have the 1 minus x sub b times N3 over 0.50 times 100. So we already know the N sub 3, then we're gonna put this one as 54. Then if you calculate this one, we're gonna have the 97.2%. So that's all.
Lita, could you back to the degree of freedom analysis? Could you show again?
Okay, Ajam. Wait a sec. Freedom. Here.
Yes, yes. This is for the overall that like we have 3 unknown and 2 balance. We have 2 components and 1 total mass balance. We have 3 equations, but only 2 independent equations, right? And also we have 1 relationship. What is the relationship? That what is this relationship?
Between the toluene and the benzene, Ajan.
For overall, that like we 3 minus 2 and minus 1. What is the one relationship? What is this information?
The relationship is the 89.2% distillation of the benzene, Ajan.
Okay, it is a recovery of benzene.
Yes.
Okay, for move to the equation B. Equation B for the next 2 slides. Could you move to the next 2 slides? Okay, for this one, you balance on the first equation. This is the 0.892. This is the percent recovery of benzene. That's right. Percent recovery of benzene. This is the amount of benzene at the top of the overhead product. 0.5 multiply 100. What is this quantity? 0.5 multiply 100. What is this quantity?
Since it is a mole percentage, Ajan, it needs to have like the times 100 to have a proposed value, Ajan.
This is the amount of benzene in the feed.
Yes.
Based on 100 mole of the total feed.
Yes.
Okay. This is the total mass of benzene in the feed is about 50 mole. Right?
Yes.
You multiply with 0.892. This is amount of benzene split out at the top of the product. Okay. And the second equation, what is kind of the balance? What is this kind of balance?
Again, Ajan.
The equation 2, right? 100 equal to N1 plus N3.
Yes.
What is this type?
This is
of the balance?
The overall balance, Ajan.
Then most of it to make the overall balance. That's like equation 1, equation 2, equation 3. This is also the overall mass balance.
Okay.
But which get you balance based on benzene, toluene, or total mass for the equation 2.
This is will be for like the 89.2 recovery for benzene.
100 equal to N1 plus N3. Is this a benzene balance, toluene balance, or total mass balance?
The entry is the for like the reboiler, John, for the
Okay, my question is, I ask you equation 2, that's 100 equal to N1 plus NT. This equation is total mass balance or benzene balance or toluene balance?
It is the bottom benzene balance, John.
Check. Yeah, this is 100 equal to N1 plus NT. I ask you, this equation is total mass balance or benzene balance or toluene balance?
The entry is the total mass, John. The total mass.
The total mass because the total feed is 100, that's right.
Yes.
And total product at the top is N1 and total product at the bottom is N3.
Entry. Yes.
Total mean we balance both benzene and toluene together. That's right. This is the total. Okay. And the second one, 0.5 multiplied 100, 0.9. This is a benzene or toluene balance.
This is for the benzene balance, John.
Yeah. I think when you write, you have to discuss more about this. This is the total mass balance, benzene balance. It's easy to understand what kind of the balance.
Okay.
We have to add more, and also if possible, you have to include the unit in the equation because the unit should be the same when you operate by addition or subtraction. You have to do that for this. Okay. But overall, your solution is your technique is correct. I only hint some when you write. You have to write the detail what kind of the balance. That's easy to understand. When I check your homework, when I check your exam. So, okay.
Okay, John.
There are any questions from friend? I could do back to the first page of the slide, but the second page I will describe more about the situation. Put you back to the first or second slide, I'm not sure, to show like the diagram of.
Here.
Okay, this is the deterioration column. It is the common known equipment that when you do the engineer and the chemical engineer or petrochemical engineer. This is the most common when you would like to produce oil, methane, benzene, kerosene, diesel, something like that from the crude oil. We have the deterioration. And the first equipment we call the feed preparation. Sometimes we have to heat the feed solution. For this case, we have two components, benzene and toluene. Right? Sometimes you preparation the feed by heating the temperature and by furnace. And then send the feed to the deterioration column. The deterioration column, we use different in vapor pressure, different in boiling point. That's right. The lower boiling point you split at the top at the vapor phase. That's right. The lower boiling point is split at the bottom at the liquid phase. And also in the bottom we have the boiler, and in the top we have condenser. We have to reboiler sometime in the mixture still not. The product at the bottom is maybe some mixture. For example, you would like to get the benzene or toluene, we get the benzene at the bottom. That's right. But we would like to set the toluene to the top. We have to reboil it. And also the condenser. We use the condenser to change the vapor phase to the liquid phase. Because commonly we store the product at the liquid phase. We store the product at the liquid phase. And also the composition of the overhead product. It is said the refract means recycle. We recycle some parts of the product into the column. And also in the boiler, we recycle the liquid or vapor from the divider to the iteration. We have some recycle. We did a common iteration operation. That's why we have the condenser to convert from vapor to liquid. And then we can collect the product at the liquid phase. At the bottom, we have the deboiler to evaporate some part of the pigment and send back to the iteration, and then split that liquid product also. I will talk the detail for the iteration when we start in the first year of the unit operation. Okay, thank you for your presentation. How about the Patricia? Are you okay?
Thank you, John.
Yeah.
Could you present the first question?
Yeah. So can I do now?
Okay, you can share your slide now.
Hello everyone. I'm Patricia and today I will present you the question 1 of homework. Where I go to my flowchart. I forgot to put on the 97% of overhead product on column 2. But yeah. So first we have to do the degree of freedom analyze. Yes. This is my unknown from column 1 and column 2, and this is my equation. The first equation is from I use information of amount of saline, the residue being 0.96, the amount of saline to solve the entry. And after that, I use overall mole on column 1 to solve N2. Then use mole balance of benzene and toluene. As same as the column 2, I use the amount of benzene to solve the N4. So this is my degree of freedom. If equal to 0, that means the system is solvable. And sorry. Yes, this is the equation from column 1, and this is my calculation. After this, go to column 2. And the last one, this is the percent of benzene and toluene recovery. Thank you.
Hello, Patricia. Could you move to the slide that we show about the degree of freedom analysis? And also, I understand what your present is, but you have to improve the presentation skill. Okay, what slide is it? Okay, this is could you explain this again? What does it mean? Could you explain the technique that to do the degree of freedom for this slide? Yeah.
Yeah, teacher. My unknown is from the anything that I write in column 1 and column 2 right here. So this is unknown there. And the 8 equation from the 4 from the 4 equation on column 1 and 4 equation on column 2.
Okay, could you move to the slide that you show the flow chart? Okay, could you make it overall balance like?
Yeah.
Okay, good. Okay, the first step. How many unknown from this? What is the unknown for the overall project from this slide? Could you tell me?
2, B2, P2, N3, N5, B5, T5, N4.
No, because you do the overall the size.
Yeah.
The overall should be digit overall. You include both column 1 and column 2.
Yeah.
The inlet to the process. This is the inlet. That's right.
Yeah.
This is the outlet. We have 3 outlets. Not include this because this is in the process. That's right. For overall, we have only consider like this. We have 4 streams for the overall. Not this. This is not overall. When you consider the overall, you have to only consider like this. This stream, this, and then we have 4 streams. And all the unknown, we have N3 is unknown, right, from the flow chart. N5, N4, XB5, XC5. This is the unknown. 1, 2, 3, 4, 5 unknown. This 5 unknown, I'm not sure. For the overall, you have 5 unknown. How many independent equations for overall?
So there
5 unknown and 3 balance equations. 3 balance. We have benzene through inside it and also total balance. And also we have only 3 independent balance. We have 4 balance equations, but only 3 independent balance. And also we know the information like 96% sign covered. And also you know the recovery of benzene at the top of the column. You know true information is the recovery at this and recovery at this. And then you know true information. We get 0 degree of freedom. You can make the full balance. And also you can do the balance around column 1. Okay, how many unknown around column 1? How many unknown? If you balance around column 1. Are you hearing me?
Okay.
How many unknown for the column 1 around the column 1?
There 4.
N2, XB2, XC2, and N3, that's right?
Yeah.
You have 4. Okay, you have 4 unknown and 3 balance equation and 1 information is 36. You get 0 degree freedom. And also you can solve for column 1. And column 2. That's right, column 2 you have 1, 2, 3, 4, 5, 6, 7. 6, 7, but you know N2, XB2, XT2 only if you balance column 1 first. That's right. Now you know 4 and also 4 minus 3 minus 1 also the 0 degree freedom. Only 1, 2, 3, 4 unknown. These 3 unknown you know already from the balance in the first column. That means you have to balance on the first column first and then balance around the second column. You cannot balance a second column first because you cannot solve because the second column we have about I'm not sure it's about 3 degree of freedom. Okay, for this case, the first step you can do right allow the first column because you get 0 degree of freedom here. And then you balance column 2. That's right, column 2. You can solve for all unknown. Okay, the next would you move to the balance around column 1. Balance around column 1. You move to the slide that you show balance around column 1.
Yes.
What is this equation?
Oh, just I show that the number of saline, but the amount of saline, but yeah, it comes to the equation below.
It feed silent, okay.
Yeah.
Feed silent. And what's this?
Yes, it formed it's in the residue being on this 0.96.
It's 96% recover.
Yeah.
Silent. That means this is amount of silent in the top product of the first column. Just like top product of the first column. For this case, you can solve for entry. Entry is the amount of mass or mole of folate, that is in terms of folate of the substance, right, or the solution in the top or the top product or the OS product of the first column. Okay. And what is this equation?
This is the overall mole balance on column 1.
Okay, this is the total mass balance. I think when you talk about the OR, it may be something you confuse OR, that means about the overall process. But I would like to total mass balance allow column 1 is better to understand. It is the total mass balance allow column 1. Right. It is 100. We have two output, N2 and N3. That's right. So N2 and N3. You know N3, you substitute N3, you can solve for N2 from here.
Yes.
And what is this equation? The third equation?
This is the mole balance of benzene and toluene.
Okay.
The upper is benzene, the lower is toluene.
There is no benzene in the bottom product.
Yeah. Yes.
No benzene in the overhead. Okay. I think we will check the understanding of the first column. I think you can solve for the second column. When you for Papicha, you have to carefully to check the degree of freedom and comment for this because very important. If you do the second column first, you cannot solve because we have degree of freedom is not 0. But if you check the column 1, okay, you get the degree of freedom of 0, and then you balance it column 2. Step 1, you have to balance column 1. Step 2, balance column 2. And also we comment like when you talk about the overall balance, but sometimes it's confused when you balance. Papicha, put you back to the flow chart. Okay. Move to the flow chart. Okay. When you talk about the overall balance, that means we balance around the overall process. Right. But sometimes in the textbook or when you write overall balance, for me it means the overall process. If you would like to balance total mass, you have to talk total mass. Like total mass. Total mass for overall column 1, total mass for the around column 2, or total mass for the overall process. Benzene balance for overall process, benzene balance for column 1, benzene balance for column 2. When you write the balance, you have to what kind of this balance. It's easy to understand when you read your homework or when I read your homework with your exam. Okay. And also the unit like Papicha is okay. You specify the unit is related to understand. The unit when you add or subtract them should be the same. Both sides of the equation. Okay. The technique is correct. If there is any question for this homework from the audience. Okay, we did the homework. We focus on the multiple unit operation with no chemical